Hello. I just want to have a chat. I noticed you're not spending so much time in the Tinkercad and SketchUp playground anymore. You want to hang out with the cool kids and SolidWorks and Onshape and Alibre. And I think it's time we had the talk. No, not the bees and the birds talk. What channel do you think you're on? Hello guys and welcome to today's video, and sorry for the cringe intro. Now today we will be indeed having the talk, but the parametric design talk, and that is about design intent, what it is, how to define it, and how does it affect our models. Really important stuff today, so let's get to it. So what is design intent? Well, it sounds like it should be pretty self-explanatory, right? It's what you intend in design, but it's not that simple. And in fact, sometimes we impart some design intent onto our 3D model without our even knowing it. And when something goes wrong, it's really hard to go back and debug it. So we will attempt a definition of that. But first, we need to discuss a bit about the hierarchy of a 3D model, right? What is it made out of? So let's say that every part that we make, right, is actually made up out of features, right? And that's where the design intent lives, in the features. But the features themselves are made out of two different things, a sketch and some parameters and options. Now there are features that don't have any sketches, like patterns and mirrors and scales and all that, but all of them do have some options and some parameters. So these two discrete elements that make up the feature is what gives it its design intent. But the heavy lifting is done in the sketches, right? So let's discuss the sketches a bit more. The sketches are made up out of sketch elements, which are lines, circle, arcs, rectangles, and so on. And in fact, I have an even deeper distinction, which is that there are primitive sketch elements and derived ones. For example, the line is a primitive sketch element, whereas the rectangle or the square is a derived sketch element that is made out of 4 lines. Then you have geometric constraints, and these are things that tell the sketch solver how these sketch elements go together. For example, in a square, all lines are equal and perpendicular to each other. So you have equal constraint, that's one, perpendicular, that's the other. And all lines are coincident end to end. So their endpoints are coincident. 3 geometric constraints there. And finally, you have the dimensions, right? And the dimensions are what tells the sketch solver in the CAD system effectively how large a sketch element is. So that's how you set up and you create a sketch, and that is how you give it its design intent. Okay. Now that we discussed about the hierarchy, well, what is a design intent? Well, the design intent is all of those characteristics of a feature that are not affected by its location or dimensions. I think that's pretty good definition of design intent. And let me give you an example. When you're making a shaft, right? It might be a large one, it might be a small one, it might be, located in the origin, coaxial to any of the 3 axes, but it is always going to be cylindrical. A shaft is always going to be cylindrical, right? So that is its design intent. The cylindricity of it is its design intent. All of the other things are things that you can also define, but it is designed and intended to be cylindrical. Now, with that in mind, let's start the sketch here, and I'll give you a little example, right? So let me make 4 lines here, right? So Alibre automatically puts in the equal constraint. I will remove it. So we have 4 lines here, and we have these two being horizontal, this one being vertical. So what am I going to do? I'm going to say that all of them are 20 millimeters. And what have I designed here? I have designed here a square, right? Well, I haven't located it in the coordinate system, but that is a square shape nonetheless. So let's do that again now, right? With a small difference here. So I will say that. So I will say here that these two lines are parallel. These two lines are parallel. They are at an angle of 90 degrees. Okay. I'll say that this is 20 and this is also 20. What do I have now? Well, I have another square. Here we got a collinear constraint going here automatically. We don't really need that. Okay, and this is what we got. We have another square. In fact, we have the exact same shape, right? Well, again, we will see. Now, let's go for a rectangle here, and I'll just say that this is 20 by 20. Oh, the second one didn't go in. So, there's the square, right? Same as the other two. So now I'll make another shape here. And what I'm doing is I'm intentionally designing away from what I want it to be, right? Because that's a way to control what constraints the CAD software is going to add automatically. With experience, you will know how that works. And what I'm going to do is I'm going to say that these lines are all equal. Okay, I want to say that this is horizontal. Let's make that equal as well. And I want to say that this is perpendicular. These two first ones are perpendicular, and that this is also 20 millimeters. Okay. So we've got 4 shapes here. Okay. How many squares are there on screen?
There can be only one.
Right? Like those silly Facebook quizzes. Well, the answer here is that on screen we have only one square. Why is that? Well, let's go through these things. Let me make this 35. That's not a square anymore. That's a trapezoid. So look, in this first shape here, we used our sketch elements and our constraints to define a set of shapes. And that set of shapes were the trapezoidal shapes. Fun fact, trapezoidal comes from a Greek root, and it basically means like a table. We then used our dimensions to get a square shape out of that set, right? But this shape is not inherently square. This is a trapezoid. Now, if we go here and change this to 60 degrees, well, what do I get? Well, I get a rhombic shape, right? So that wasn't a square after all either. That was a set of rhombic shapes, and we used our dimensions to get a square out of that set. Well, this one's easy. We made it using a tool called rectangle. So it's the rectangle shapes, right? But in this final one, whatever we do with the dimension here, we always get a square. So only this final one is defined to be a set of square shapes. And then we use the dimension to pull out the exact square that we want out of it. Okay, so only this one is a square. So let's delete all 3 of these and let's focus on our square, right? So I'm going to use my midpoint constraint with 3 points, and then I'll do the same on the other diagonal. And now I have placed this centered about the origin. That's another design intent. Why does that provide some design intent? Well, let's say that I extrude this for 5 millimeters. The way I placed the original sketch, now the YZ plane, the ZX plane are symmetry planes of the shape. Let's go back into the extrude. I held Control, double clicked, and I'm back into the extrude command. Now, I extruded this for a depth of 5 millimeters, right? Now, if I make this 20 millimeters, I have a cube. But what is the design intent here, right? Well, the design intent is not a cube. It's a cuboid, parallelepiped, or whatever you want to call it, with a square base and a height of 20. So if I go into my sketch and I make this 35, it was 18, by the way. So if I make this 35, well, it's not a cube anymore. Well, it never was technically, but I thought it was. So that's the design intent, right? That it has a height of 20. Now, if I hold Control, double click, and go back in here again, and I click on my FX icon, I go and I say that the depth now is D8, right? It's whatever the dimension in the sketch was. Well, now it's a cube, okay? And if I go and change this to 20, again, it's a cube. So that's how a parameter of a feature imports some design intent into our model. And finally, look at this. Type, hit plane. So that was not a parameter, that was an option. And what did it do? It said that the plane I was designing on, the XY plane, is also a symmetry plane. So all of the three basic planes now are symmetry planes of my 3D model. And of course, playing with any other of these options and parameters will create some design intent that is then carried over to the next one. So that's my take on design intent. That's how I define it, and that's how I use it. And I hope you find this helpful and you make better parts and more robust parts because of it. And if you liked it, hit the like button. If you liked it very, very much, hit the subscribe button. And maybe watch a couple more videos. Thank you so much, and I'll catch you in the next one.